Dear students, in last video I told you about Rutherford atom model. Rutherford told that atom has a whole neutral but has negative and positive charge in the form of electrons and protons, and he told that total mass and positive charge distributed uniformly over the whole volume of atom. But that model could not explain anything about the spectrum of light emitted by different elements. And since the radiation emitted is supposed to be due to the interaction of atoms or molecules of solid with each other, in case of gases, the atoms are far away from each other, so the radiation emitted are supposed to be by gases due to atoms. Hydrogen being lightest one, simplest one, shows many spectral line, some visible light, some other. I will be discussing later on. So Rutherford in fact was engaged with radioactive radiations and elements, and he proposed that if total positive charge and mass of the atom is distributed uniformly over the whole volume of atom, then if we bombard positively charged particle on metal sheets, that should be reflected back. On this suggestion, in 1911, so Rutherford suggested that if total positive charge and mass of atoms is distributed uniformly over the whole volume of atom, then positively charged particle bombarded on metal sheets should be scattered back. But Thomson told that total positive charge and mass is distributed uniformly. But that model I told you could not explain anything about the spectrum of each atom. So he thought like that. On this suggestion, hence Geiger and Ernst Marsden. Two undergraduate students of Rutherford in 1911 performed alpha scattering experiment. One year there was a question who performed alpha scattering experiment. Student wrote like this, answered Rutherford, no. Hence Geiger and Ernst Marsden performed this experiment. Okay, suggestion was given by Rutherford to check the validity of Thomson model. But this experiment was performed by Geiger and Marsden, please, in 1911. Then what was the experiment? Alpha particle. What is alpha particle? Alpha particle is helium nucleus. Alpha particle, first of all, let me tell this. Alpha particle is helium nucleus, represented by 2He4. Means it has two proton, 2E plus charge, and 4 mass, 2 proton, 2 neutron. These alpha particles were available from radioactive element 84 83 bismuth 234 83 Bi 214 83 adjacent for you it is new thing, almost many of you may know, and I will be telling you. This represents atom number. In modern physics, modern chemistry, 83 represent atom number which is equal to the number of protons present in the nucleus, and 240 is the mass number. Sorry, it is 214 mass number that represents sum of protons and neutrons present in the nucleus of the element. I hope you radioactive element bismuth emits alpha particle. We will be learning radioactive later on. Radioactivity is very important chapter, but our educationists, I don't know what they are doing. They are deleting the syllabus, which is very harmful. They are cutting the knowledge of the students. In previous syllabus, students were performing well. They were obtaining more than 90 marks, 100 marks also. Many students have got more than 95% marks. One got 100% marks from the same syllabus. I don't know what is happening. So please you be sincere. Try to grab the knowledge. So alpha particle experiment. Actually, we need alpha particle. I told you helium nucleus is alpha particle. It has 2 protons, 2 neutrons. Neutron is neutral particle, but mass of proton neutron nearly same. They are different, but we can say nearly same. Proton has positive charge plus E. So 2E. These were obtained from this bismuth, radioactive element 83 Bi, and their kind energy was 5.5 MeV. MeV means million electron volt. I have told many times 1 million electron volt means 10 to the power 6 electron volt. अभी भी जिक्र करेंगे हम equal to 1.6 10 to the power minus 13 joule. Though this is very small unit, but for particle like proton, this is a large value of energy. So Rutherford suggested this experiment, and his two students who were under graduation performed alpha particle, and for that they got Nobel Prize also. Later on, in I think 1915, Rutherford, anyway. तो व्हाट इज अल्फा स्कैटरिंग, ये जानना जरूरी है. व्हाट इज अल्फा स्कैटरिंग एक्सपेरिमेंट? You have to learn this thing. First of all, I told it was performed by Geiger and Marsden. Hence Geiger and Ernst Marsden. Here they took a source of alpha particle bismuth, just I told you. Here is the source. A narrow beam obtained by passing through two bricks of lead. Lead actually absorbs alpha particle, and there is narrow hole. So these are lead bricks. Lead bricks. A very narrow beam. Here was a screen, zinc sulfide screen. Zinc sulfide screen. Actually, why this? When any charged particle fall on this screen, light flashes are produced, which are called scintillations, bright spots, and they were observed by a microscope here. Microscope. Now, when there was nothing, the scintillation were observed here. Then, actually, Geiger and Marsden use here a thin sheet of gold. Thin sheet of gold here. Gold, or we say gold foil. Why gold foil? Helium nucleus coming from this, alpha particle coming from this, has mass, has energy 5.5 MeV, and mass 4 times the mass of neutron or proton. If we take any other element other than gold foil, the nucleus may be light one. The mass of the gold nucleus, nearly 50 times heavier. So when alpha particle collide with that may remain stationary. If you take a light particle, that can be just like if two balls collide, then ball at rest will also move. So the gold nucleus remain in its own place, and we can obtain a thinnest sheet, because gold is most malleable material. A thinnest sheet of the order of thickness 10 to the power minus 7 meter can be obtained. Gold is taken because of heavy nucleus, and we can obtain thinnest sheet. So when this was placed here, alpha particle were scattered. Actually, scintillation were obtained this way, and also here I can't say, they were found to be scattered back also. There is one diagram here in this book NCRT. You can see here this diagram, and this is the diagram. Generally in class 12, examiner generally asks, okay, draw the diagram of alpha particle, alpha scattering experiment. Sort of diagram. In class 12 exam, generally questions of 20 or 30 marks, 20 or 23 marks are for diagrams. Because many question need diagram, or sometimes they only ask label diagram. तो इतनी अल्फा पार्टिकल है ना, सोर्स ऑफ अल्फा पार्टिकल, सोर्स ऑफ अल्फा पार्टिकल्स. What is this? 83 BI 214. Please learn this terminology. Learn the name of element, their mass number, their atom number. I told atom number is the number of protons present in nucleus. Mass number is the sum of proton neutron. So these were actually, these simulations were observed around it. Not telling detail, you can read the book. Now I mainly will be focusing here myself on the result of alpha particles. So I think diagram is clear. Now I take here observations. There is one diagram also. Theta angle of scattering and number of alpha particle. Number of alpha particles. एक साली diagram पूछ लिया. तो here it is. Suppose 90 degree, it is 180 degree, it is 0 degree. So the graph y like this. I will discuss what is this. Telling you number of alpha particles. In this number is in millions, 10 to the power 7, 10 to the power 6, like that, and so on. So main observations of alpha particle. First observation, I should say right one only. Number one, most of the alpha particles passed through gold foil without any deviation. Instead of reflecting back, they pass through gold foil without any deviation. Simple one. The result we will discuss later on. Number two. A small number of alpha particle were scattered at, here is small number, this is the number, sorry, this is a big number and large number. So this big number without deviation, theta is very small. This is the angle of scattering. So a small number of particles were scattered at large angle. 10 to the power 7. Simple. Were scattered at large angle. And number 3. Number 3. Out of nearly 10,000 alpha particles, only one alpha particle was scattered back. So these were 3 observations taken by Marsden and Geiger. They took only observations. They performed this experiment, and for this they got a Nobel Prize also. अभी लिखा था यहाँ बुक में हमारे कहीं. And then they discussed with Rutherford, sir, these are the observations. So in next video I will be telling you Rutherford conclusion and Rutherford atom model. Please continue to study with me. You will be benefited. Like the videos, share the videos, and ask your friend to subscribe my channel.